So in this video, I want to work on problem 1 from precept 4. So here we are starting with this data frame for 1952. So that's going to be like that. So our first task is to plot log 10 life expectancy versus log 10 GDP per capita. So we go ggplot, and we say G1952. So that's what we want to do. So we want a scatter plot and a straight line. So to do a scatter plot, we say geom point. So here, because the mapping is the same, we can specify the mapping in the call to ggplot. So we'll say x is going to be GDP per capita, and y is going to be life expectancy. And then we can say plus geom point, and whatever we set here is going to transfer here unless we override it. So here so geom point displays life expectancy versus GDP per capita. So we also want a straight line, so we would say geom smooth, and we'll say method equals lm. So the method equals lm makes it a straight line. Okay. So now actually we want log 10 of life expectancy, log 10 GDP per capita. So we'll say scale x log 10. And we also want to say scale y log 10, so that both the x and the y-axis are computed like that. If we want to be really nice about it, we'd also display the $sign. So we'll say scale x, and we'll say here labels is dollar, like this. So you need to say scales like this. So scales dollar here, and here you'll have GDP per capita displayed in dollars. Life expectancy is just in years, so don't need anything. So that is the plot. So the only thing to note here is we said mapping here, so that applies to both geom point and geom smooth. You could in principle specify a different mapping for geom point and geom smooth. Then you'd have to do this here or here. Okay. So now what we're asked to do is we're asked to fill in the blanks for this kind of thing. So this is log like this, so we just assume it's the natural log. So what we'll do is we'll try to predict life expectancy from GDP per capita. So we'll say lm log life expectancy log GDP per capita. So that R knows what we're talking about, we need to specify that life expectancy and GDP per capita are columns of G1952. So if we run this, we'll get that this is the intercept, this is the coefficient for log GDP per capita. So the way you'd predict log of life expectancy from log of GDP per capita is this plus this much times the log of the GDP per capita. So that would be the estimated log life expectancy. Can't really write it nicely here, so we'll just do like estimated log life expectancy like this is the intercept plus the coefficient times log GDP per capita. So now what we're asked to do is to write a function that takes in a GDP per capita figure and A0 and A1, and it returns the predicted life expectancy. Okay. So we're giving the function signature here. So the function signature is just kind of the first line of when you're defining a function. So it's supposed to look like this. So you're taking A0 and A1, and you're taking a GDP per capita. In general, when I'm asking you to write a function, you want to just only use the information that's available to you here. So you want to use A0 and A1 and GDP per capita. Okay. So to predict the log of the life expectancy, you do A0 plus A1 times GDP per capita log, right? But that's the predicted log life expectancy. So if you want to go back to just predicting life expectancy, one thing you could do is you can say exp of this. So I should say this is not exactly the expected life expectancy because there are complications there, but you can make this be kind of the predicted life expectancy. That's going to be like that. So we can now try it. So we can say my pred, and then we can say that A0 is this much, and then A1 is this much. And then we can put in whatever GDP per capita we want. So for example, if you want 10,000, we can do it like that. So we got that the predicted life expectancy for a GDP per capita of 10,000 is 63. For 20,000, it's 71. For 40,000, it's 81. Okay. So now what we want to do is we want to characterize the relationship between the predicted between the GDP per capita and the predicted life expectancy. So let's just pull up the solutions. So here it's a little bit tough to type all of that in real time. So we're predicting log of life expectancy like this. So if you're increasing log of GDP per capita by 1, what does it mean? It means that that's the same as saying GDP per capita grew by a factor of E. Okay? Why? Because of this. So log of GDP per capita plus 1 is the same as this, is the same as log GDP per capita exp of 1, which is the same as log of GDP per capita times E. So if we increase log of GDP per capita by 1, what does it mean for log life expectancy? So like you used to have this, and then you have A0 plus A1 times log GDP per capita plus 1. So the plus 1 multiplies A1, right? So if this grows by 1, then this, the predicted this, grows by A1, right? Because it's like A1 times log GDP per capita plus 1. So, okay. So what does it mean for log life expectancy to increase by A1? It means that we're multiplying the predicted life expectancy by E to the power of A1. You can check. And now we can just see that, well, an increase by a factor of about 2.7 GDP per capita corresponds to about a 20%, 19% increase in predicted life expectancy. Okay? So that's like that.